fellow programming engineers, welcome back once more to this drives course. And today it's going to be pretty simple, guys, because we're going to be looking into a stop type topics or stop method. Now, what do I mean by this? In drives, generally, there are two different types of stops in our motor. Now, careful, guys. Do not get this confused with our reference, our start reference, okay? Because there is no stop reference. It's something completely different. If I choose as a reference, as a stop reference, to be used for digital entries, the external digital entries, then they're all going to be start, stop, turn, switch. These are all as external inputs. I can't run them as combinations. It's a start-stop method. So they're all using the same reference. So don't get this confused, guys. So here on our stop method, we're going to choose whatever we used, whether it's communications, external communications, etc. The method is coast to stop or ramp to stop. Okay? So the ramp method, which is ramp, or coast to stop, is through inertia. Okay? So basically, what do I mean by this? So we're running, again, our manual, and we have here two manuals. One in Spanish and another one in English. Now, why am I opening both of these? So that you guys can see, and you guys can see how we can look for coast to stop. One of the methods of stoppage is coast to stop, and the other one is ramp to stop. Now, when it says ramp to stop, well, I actually want us to look into, let's see here. I want us to look into a chart to look at the differences. Fast stop, but there should be another one. Here it is. Here, okay. So, for example, it says here, run command selection, which is our start, okay, which is what I was saying, our command selection number 1. And in this case, it has nothing to do with our drive keys. The other one for our entries, our entry terminals, the communication part, and the other one is for the PCB. But we are always going to have our stop method. The default part comes on behalf of the ramp. Now, what does this mean by ramp? Do you remember what I told you about deceleration? Well, if we select this ramp option, it's going to listen to this deceleration time, okay? Which means that the stop method is going to be commanded. Now, who's commanding this? Our drive. And who's configuring our drive? We did. Our motor should listen to the established time or the set time within our drive in the deceleration part. That's the only thing. That option is, remember, if it's for ramp, that's going to listen to the deceleration time that we command or that we tell the drive. Okay? So ramp to stop listens to the deceleration. So coast to stop remember a key word here, inertia. So what this does is it runs inertia until it stops. Okay? Now, what does inertia mean by this? When it's ramped to stop, again, going back to the first option, drive is going to command that time in our motor. Now, why is this done? This means that it's going to be sending out a voltage. Firstly, when it's in nominal speed, that is going to have a stator voltage for the motor. Okay, so that means that the voltage is going to be controlled over the motor. And only that way are we going to be able to command our motor. If we wish to decelerate our motor, what do you think is going to happen with that voltage in our stator? Do you think that it's going to remove that voltage from one point to another? No, right? So when we press stop or a stop button, it will gradually decrease. It will gradually decrease our stator voltage. And that calculation, the drive already knows how much to decrease so that it gets to the desired deceleration. So that means that it's going to be removing that voltage until it gets to 0. Now, what happens with our coast to stop? If we select this option at the moment when we press our button for our stop, it's not going to respect really our deceleration ramp. Okay, so they're not really interested in our drive. Now, what are they going to do then? They're going to remove the voltage from the stator, from one point to the next. So therefore, that motor shaft, logically because of the speed, already has inertia. And it's going to stop naturally for that shaft, because it's going to stop due to inertia until it's at 0 hertz, which means until it has no speed at all. And then it's going to respect the velocity ramp, the deceleration, sorry. So it's going to respect the deceleration time. This respects nothing. When this says stop, it's going to remove all velocity from the stator, and it's going to start braking by inertia. How long will this take? I don't really know, depending on the inertia that it has. So generally, our time for deceleration is going to give us the opportunity to command this because we have this first option, ramp to stop. So if we want inertia, we're going to select our second option. And both these options, ramp to stop and coast to stop, are the most common ones and the most used ones in our drives for any brand. And they're run by these two options. Do we have more? Of course, it all depends on the drive. But the option is through brake, our brake resistance. We're going to look into this into the future a little bit more clear, but I just don't want you guys to get confused. So if it says, if you're going to brake, only brake with your inertia. So this means only brake with voltage, resistance. And that way you're going to listen to whoever commands resistance. So if you get the instruction to stop from one moment to another, I don't really care. The one who's going to give you that command is not going to be the drive, it's not going to be resistance, but the brake resistance. And the other option in the Yaskawa drives, it means that you're going to stop with an inertia, but within a commanded driver. It's not the same thing, our deceleration. So it seems that there's a lot of similarities between the both of them, but it's not really. Because we're going to add a timer, an external timer, before that time comes. And it should stop. So if we tell it to stop in 5 seconds, there's going to be some inertia in that time. If it sees that it's not enough time, it means that it's not going to comply with that time. Now, it's not really necessary that it stops for the 5 seconds before I press this, but for inertia within a timer. Okay, so it'll be within that time, because the zero option, or the ramp to stop, if I tell it to stop in 5 seconds, it is going to stop at 5 seconds. If here for coast with timers, it's not necessary, and it's not going to respect or guarantee that it stops at 5 seconds. So it could stop before, or it could stop at the end, depending on the inertia that the motor shaft has. So it could stop at 2, 3, 4 seconds. But if we want that to be the option, that would be option 0. So these are the difference between our stop method. Now, why did I look for this in English? Because in Spanish, it has many differences. For example, here it says stop method, and other methods say halt method or detention method. So here it says coast to stop. They were unable to really translate this. So there are some other manuals that say inertia detention, and others say stop by for inertia, or stop by inertia, and others say coast stop. So it's really, I already recommended that they have English manuals and try to avoid the Spanish manuals. So in this case, if you want to look for coast, I recommend that you look for these words that you're looking for. So here our ramp is coast to stop. And here, for example, it's going to say ramp to stop. And here, for example, for coast, which is the same thing as this side, coast, it does translate to inertia. So you need to be very careful when looking for the words in your manual in Spanish. So with this, we will be done with our stop method within our drive. So we're going to move on to our next one. Big hug, guys.